International Conference on Sustainable Engineering and Materials Development, ICSEMD 2021. As a participant of the 2021 International Conference on Sustainable Engineering and Materials Development, you are now part of a community poised towards contributing to a better tomorrow. This community consists of scientists, engineers, members of academic and research institutions, students, industry players across the globe, and organizers of this event that will be interacting on a 3-day virtual conference on sustainable engineering and materials development. Renowned professionals that will be gracing the occasion are ICSEMD 2021 is an incredible platform to network with top professionals in sustainable engineering and materials development. In preparation for this event, thorough peer review was done by the Technical Review Committee, and good decisions were arrived at accepting top papers based on scientific content and structure. In that regard, the organizing committee advises that you proceed with your registration and prepare for the conference held September 22 to 24, 2021. Kindly proceed to register for the conference and make your payment by creating an account or logging into your account on www.labingate.com. Click on the ICSEMD payment from your profile and generate an invoice. Further communications about the conference will be made available to all participants. Many thanks to ICSEMD 2021 partners, Labingate Incorporated, Canada, and Bells University of Technology, Nigeria, and exhibitors, CERC Malaysia, Centralized Analytical Laboratory, CAL, University Teknologi Petronas Malaysia, Planet 3R. We are looking forward to seeing you at the conference. Watch out for ICSEMD 2022.
Professor, I must say that looking at his CV and reading his CV and the things he has achieved in this lifetime is remarkable. And so I'm going to introduce him. He's a guest speaker for today. So I will start by introducing him. I must also say that he is one of the senior executive team members of Bells University of Technology in Northern Nigeria, and one of the partners of this year's 2021 conference. So Prof and your team, we thank you so much for coming. Now, Professor Sunday Isaac Fayomi is the Dean of the College of Engineering, the Chairman of Corporate Affairs Unit in the Office of the Vice Chancellor, Bells University of Technology in Northern Nigeria. He is an internationally renowned researcher, teacher, and life coach. He is an established and a proven academic in the area of mechanical metallurgy. He has several degrees, but the most important ones are his master's and doctoral degree was in metallurgical engineering with distinction, cum laude from the Department of Chemical, Metallurgical, and Materials Engineering in Tshwane University of Technology, Pretoria, South Africa. He also has a postgraduate diploma in environmental and natural resource management. Professor Fayomi has been lecturing in the university and research environment since 2007. He rose to a distinguished, exceptional professor with massive contribution to materials development. He is also a visiting professor and researcher to a number of institutions, which I want to name a few. So basically, he's a research director at the Surface Engineering Research Center, Research and Innovation Associate with the Tshwane University of Technology in Pretoria, where he trained and mentored over 150 training students. He has, to his credit, over 500 indexed international and local peer-reviewed journals with substantial impact factors, broad readership, citation in Scopus and Web of Science. Professor Fayomi is an external examiner to several Nigerian universities at both undergraduate, postgraduate, and some foreign universities, among others. For instance, the University of Johannesburg. He has supervised over 150 international research and industrial projects, graduated 7 doctoral degree holders, 15 master's students, apart from ongoing postgraduate supervision. Professor Fayomi is a sought-after inspirational public speaker and lecturer to many industries, universities, and institutions. Professor Fayomi is also a reviewer to highly sought-after scientific and academic journals in the field, published by Elsevier, Springer, Taylor, and Francis Wiley, just to name a few. I can continue and continue, but these are some of the things that he currently won. He is also an external examiner of the National Research Foundation in South Africa, Portugal, and the technical chair of one of the most sought largest research conference gathering in Africa, is ICEWS. He's the co-chairman of the Standards and Dreaders with the Standard Organization of Nigeria. He's a member of several engineering bodies such as the Council for Regulation of Engineering in Nigeria, COREN, member Nigeria Society of Engineers, registered academic member Writers Institute of South Africa, member Nigeria Metallurgical Society, member Nigeria Association of Technologists in Engineering. He is an achieved researcher and lecturer. He has harvested, I like this word, he has harvested numerous awards. The Scientific Achievement Award of the Southern Africa Society for Advancement in Science Medal for original research. Fayomi was a postdoctoral researcher and awardee of the institution's Best Postdoctoral Fellow for Teaching and Innovation at the Tshwane University of Technology. He also emerged as the Best Doctoral Degree Award student at Tshwane University of Technology. He is a well-reputed nationally and internationally in areas of mechanical materials mechanics. He was named as an outstanding African researcher in 2019 and the most innovative scholar in composite deposition. According to 2017 to 2020, a rating of he was rated as globally by the Elsevier Scopus. Professor Fayomi is the #1 researcher globally by the Scopus. I can also continue now, but then above all, Professor Fayomi is a family man, married to the sweetheart called Gloria, and they are blessed with 2 children, Isaac Jr. and Triumph. Professor Fayomi, the floor is over to you, and please join me, welcome this distinguished son of the soil, of the African soil, Professor Fayomi. Over to you, and thank you so much for coming. Thank you so much for making time, and more importantly, thank you for allowing your university to be a collaborator in this year's 2021 conference. Thank you so much, sir. Over to you.
Thank you, Dr. Desmond Idem. Thank you for giving me the privilege to be here. You guys hear me? Can everybody hear me?
Yes, Prof, we can hear you. Go ahead, sir.
I'll be sharing my slides right away. The organizer of this great conference to be here with you to just to share a few words with you.
Yes, Prof, we can see your screen.
Just to honor this event. And I have my senior colleagues and erudite scholars here present, Professor Ajayi, and many other people in Osborne. I will be very brief today because I have to rush back to the meeting with you and see where we can navigate and move on to. By form of introduction, let me bring you best University of Technology. I think one of the best is the University of, is the first university, private university of technology in Nigeria, as a matter of fact, and we are giving live to the society. As we all know, I'll be speaking to you this morning on where we have on the part of the world on, I said, material in a new age adventure, materials in a new College of Engineering, best University of Technology in Nigeria. Why trying to, I said we are in a material society, and our evolving world needs greener and stronger. We all will agree with me on this perspective. Material comes everything, and at the same time, it limits our capability. It controls everything, but it also limits. It is essential to our survival in an increasing technological and material dependence. And we know, no matter the level of advancement, materials and its compositions over time. We can only go far with materials and its composition. So the world is revolving and having some evolution of materials over time, from the age of Stone Age to now to the composite materials age, and now the future is talking about nanos, going on with nanomaterials. So materials have allowed humans to progress from its early beginning, before into a new phase. So we have to begin to change our thinking on how we is believing. That means everything we hold contain a where we are seated today, where we are talking about. So we see it's all about discovery. And that is why I said here, the science of material is applicable to every field. The science of material, every field of human endeavor. But you see, the following fields are considered because of the aerospace. We can see that material, we can't do anything without material. We have aerospace materials in which we have a new space because the world is revolving. Everything about aerospace, we talk about materials. Defense, we talk about the materials in defense and those high jet defense materials, supersonic material jets. These are all produced through materials evolution. Then we have what we call those of us in biomedical applications, in which we have to intermorphose our materials usage into what we biomedical implants. So it's all about materials. So we can't do without material. About the semiconductors in all spheres, the with semiconductors and zinc, infusions. These are all electronics made with materials. Then we talk about the oil and gas. We saw the evolution of materials moving from the gas pipelines even to the where we want to control them. But you see, even when materials are everywhere, we can also not do without its deterioration. That is very important. But we have deterioration all over the space. Now we have the oil and gas and the deterioration of the oil and gas. Materials have to come in place by finding a way to reduce the failure rate of this material. But see, I'm trying to show you some of the catastrophe we see due to corrosions and mitigations of corrosions place. Now, what are we going to do? Materials, especially in recent time, they have these good properties, high strength, availability, but they still go bad. And we can't allow them to go bad because they are finding challenges have been becoming something, uncontrollable. So there is a need. From studies, it has been realized that 80% of steel components are made up of my steel. They are challenges of corrosion. And what are we going to do? Despite this specific characteristic, and also provide sustainable materials towards it. Their corrosions, susceptibility to corrosions evolve. We know my season have topological properties, abilities as we know. So from studies, we also know that about a statistics of about 3.4% of global GDP being down.
Hello, everyone. Can I suggest that we turn off our cameras so that the good professor can present and use his own camera, please, so that we can save some bandwidth for them. I think that is why there is interference. But Prof, go ahead. Prof, it seems you are muted.
Am I on now, please?
You are audible now. Go ahead, sir.
Thank you very much. We have, despite the challenges we are having with oil and marine industry, now we have to find a way to combat it with the issue of materials. There are a lot of methods that have been used. Alloy, the cathodic protections of coatings. Coatings have been preferred by galvanizing or manners. But you see, can we look for simple techniques to improve operation? Maybe versatility of that materials, hybrid limitations, especially when we're trying to look at weight reductions or what I call are these, as a matter of fact. In my own research, effort has been made over decades to find a way in developing stable ordinary zinc addition of nickel and cobalt and nickels over time. You know, you see from my citation, there are and now we have to be integrated, what I call the composite integration into zinc alloys and from agro-based, you know, infusion. And by so doing, you know, these are studies I've done. Binary depositions of coating, you have to improve from there into what we call the ternary depositions of coating, what we call the multi-component ternary deposition of coatings, just for corrosion mitigations and improvement time. Now, more importantly, despite the fact that there's major three problems that always arise to steel. Number, challenge of structural deformation. Three problems, majorly. Challenge of structural deformation, areas, and threat as a result of the harsh conditions where those materials have been applied over time. Able to come up with something. I said, okay, these are my research plans for this topic, what I'm going to present today. We try to manufacture a composite particulate strengthening materials of this series with aluminum, titanium in the presence of eco-friendly, you know, materials. And from our studies, when you apply this methodology, it's a material deposition methodology over time. We select the material, we do some what we call deposition techniques. Then we try to characterize the properties that we involve. Two techniques, schematic diagram of the design of composition that we're able to use over time, and the evolution of the coating here. Within these, the cathode. Then these are the anode in the cathode, and within the electricity, you know. So the electrolyte has been developed here with eco-friendly materials to be able to see the effect. But from all sense of we understand that material with solanum, right, formation in chloride bath. But material with solanum produce a very, very effective good one. We try to see can really meet up with this. And so we develop a conditioner bath. We breed cotton. This is picture solanum that we use. This to be able to see the effect of what we are trying to do against this. Now, this is the methodological example here. You know, without with little peaks and around the corner. But you see, this is just received materials of the zinc titanium. When it's being added with solanum, so these are received, so there's an improvement here. But you see, without solanum, after the solanum, we see that there are better fine grain structures which is expected of the material. And after that, we try to study, you know, using the AFM atomic force microaggressions that occurs within the two. This material very good morphological and topography across board with the system having Solano. Now, we also do some little, X-ray diffractions analysis to be able to see the peak formation. The intensities of this in at 12,000 is also still giving us a very big, good, the Bragg's angles, and with the presence of the expected, ought to be appears, which are also there, as expected, the materials also. This is the as received sample at 33.5. Without the Solano, we have 9.2. And with the addition of Solano, we have an increase of 334, 0.6 HV over what I call the eco-friendly or nanocomposite material that we have to form the electrolyte. So we have an improved hardness twice, from this study. And this is also the wear property. We try to do the wear deformation behavior. See, we have a very low, very. You look at Solano also, it's still performing very effectively, compared to the one who doesn't have. And after this, we try to look at the coefficient of frictions. You see, the received sample having a high one, with us with Solano having a very low coefficient of friction, including again the sliding velocity. You can see the one very good structure across board with these. So that shows us that the importance of nanoform. So we did the corrosion test, the corrosion result of it also the same result. Materials having a better, infusion. Materials world is a unique one. You can play with materials and get, and that is where the impression of for coating effect. After the thermal studies, we try to do thermal stability studies. We also see within the one with Solano. Without Solano, we see all these peak up. But with the one with Solano, there is stability. There is stability grades across the interface and materials. That's stability within. We have a very fine grades across. Solano really brings about stability. Eco-friendly material brings about stability of the coating produced. The future of materials is not, and the future of materials is all about smart materials in graph. So we have also nanotechnology. So we have to begin to look into that. That is the future of materials. Any material we have an effective, improvement against. Is where all materials engineers must begin to look into what we call the smart materials now, the wonders materials, the process improvement over time. And in conclusion, ladies and gentlemen, in the world of materials, things keep on improving. We have to improve. Things we have to involve. We have, to provide in our work into what we call smart materials. Graphenes, my only to smart materials or smart solenones to induce what I call original composite material. I try to publish it to say one of the high Q journals. You can see it's an CBI journal. See, using this composite, then I have Solano here. I try to publish it there, and they gave me a very good. Should be able to publish it, and I will say thank you, ladies and gentlemen, for giving me a privilege to be here. Thank this wonderful conference. I wish you a very good success.
Thank you so much, Prof. I know that the network was a bit funny, but we thank you so much for your presentation. And I also share the same sentiment. Like yesterday during my presentation, I was telling the group that it is estimated that the galaxy has about 10 to the power 66 atoms and 10 to the power 80 atoms in the universe. However, materials that we know currently is about 1 trillion, and materials yet to be discovered, there's like one Google. One Google is 10 to the power 100. And so I share the sentiment that materials are the foundations to engineering technology. I jokingly tell my colleagues that they are engineering material. They are good conductor of electricity because they contain 70% of water and they are made of ceramics. So Prof, thank you so much for such an incisive presentation, and you've set the tone for us as we go into the parallel. So you've set the tone for us as we go into the parallel session, where we are going to begin to look at what people are doing across the world, interact with them, and try to see how we can go. And so, Prof, once again, on behalf of the organizing committee, we want to thank you so much for giving us the opportunity to rent a space in your calendar and for you to share this wonderful work that you are doing. You've shown that it can be done, and you continue to move things. And so, Prof, we are so grateful and we thank you for coming. Having said that, we are going to the second segment of the parallel discussions. Prof, you want to have a few words before we... Hello, Prof.
I'm with you.
Good. I think that it will be remiss of me if I don't give the opportunity to some people to ask some questions. So can I please request that if you have any question, you should. I think, Prof, we should do that, because with a person of your caliber, it will be very interesting for our participant to interact with you. So please, can I welcome some few questions before the professor take exit? I know you did say that you'll be running to another meeting. So can we welcome some comments, yes, feedback, or questions? The floor is open, please.
Thank you very much. Thank you, Prof. That was a wonderful presentation. We really appreciate what you're doing in the world of research and materials development. I'm very, very interested in that Solanum presentation I just gave now. It's an eyes opener. I just want to ask a question. What really is the thing helping the system when you use Solanum as a protective medium? Is there any mechanism or kind of kinetics or maybe formation of something that is helping? Because apart from corrosion inhibition, you talked about the increase in the hardness and the wear resistance. So is there anything that forms, or is it based on refining of grains or whatever that led to the increase in the performance of the materials? Thank you.
Should I answer that first?
Yes, Prof. Go for it, Prof.
The question is from the first agro or eco composition that was made up of it. You know, is try to, because before now we have to be looking materials to use for you know, enhancer, you know, and an enhancer is more of a stabilizer, is in form of it gives us the choice of it actually is based because of this stable composition or characteristics within them. So after choosing those, thing to do is to admix it into, you know, from the first study that I have, that there is always what they call stress induced at my structural behavior. Over I develop, I always realize that there is always structural induced. I mean, structural cracks. Stress is always seen at the top. So I use these structural parts without have to look for chemicals again to be inducing into this soft. So, you know, find a way to reduce that thing. is a very good inhibitive material. So now, material, then let me see if I can apply it to what we call coating. So when I apply it, I realized that the pores were closed. There is no stress induced anymore. You know, the thermal, that's why when you look at the thermal result entirely, the improvement, in fact, it's also harder to the hardness behavior of material that or the grooves that are supposed to open up within. When you are dealing with structure, you are talking about interfaces also, especially as a result of coatings. So one of the pores in coatings, you must be looking for a binder or a stabilizer, and that way as a binder, as a stabilizer, and also as an enhancer to coating. Oh, it is because of its composition.
Thank you, sir. Excellent response. Thank you.
Yeah.
Any more? Any more, please? This is an opportunity. We don't get such opportunity with a man of such caliber. So this is an opportunity to answer, to ask questions. The floor is still open. Hello, Prof.
Hello, everyone.
Okay, yes, go for it, sir.
Hello, everyone. Thank you for this opportunity, and thank you, Prof. Fayomi, for this great session. I have a question toward the next year of material sciences, in parallel with the intense rising of intelligence technology. Could the material reach the stage that can restructuring their molecular structure, that can reach the specific mechanical abilities without the need of human, according to the intelligence, according to enhanced materials that could be able to be programmed, or something like this. I hope you get the point and was clear for you.
Okay. You're talking about.
Do you hear me, Prof. Fayomi?
Yes, I'm with you. I wanted to get the question very well, please.
Okay, as simple as it's possible. We have intelligence technology, artificial intelligence technology, yes, that's rising very fast. And we have in parallel the material sciences are rising to enhancing the ability, mechanical ability of the materials. Could the materials in the next future, close future, reach the state of restructuring themselves to be rehabilitated with their environment, with their functions, without the need of third party of or mankind to reprogram them, material doing their rehabilitation by themselves?
Yeah, I think I get you now.
Okay, thank you.
Yeah. Now, you see, the question is, there is what we call material development. With new material development, there is what we also talk about the usage of materials. Two things is different. I can develop a materials for a company, plus part for a company. Now, it has to pass through a lot of series. You see, it's like informing. Take for instance now, it takes time for you to develop a material, an aerospace, because it has to go through a lot of ISOs. presently now, so new material development is one way, one thing. Another thing is some people specialize in new material development. Some people specialize in application of new materials to, to multifunctional aspects. So it depends. Many people now picking the material developed for an advanced application. That is what you are talking about. Some is like, artificial intelligence, for, smart materials. I tried in my introduction, I'm trying to give you a background of what is happening in the new materials world. But it takes time to revolve around applications of a particular materials. It's revolving. It starts from material development, lightweight material, then it will now metamorphose into the applications of those materials. So people like you who is in artificial intelligence, you can materials, you make use of the material developed, which has passed through a lot of process into anyhow you want to make use of as a wide. And I want you to believe that it's wide, very wide, it's very vast, it's very wide. So depending on how you're coming from, like me now, as a matter of fact, I deal mostly on what I call new developing materials. So I give it to industry, okay, look at this material I've developed, what can you do with it? What we're doing, in South Africa, I was able to develop an electrolyte for a material functions, that the new small scale industry have to use it. Why? So that is one part. I'm not there to use it for them. Another, even the new study now, we are talking about integrated engineering. I don't know if you understand. There is a new concept of engineering in which all aspects of engineering comes together. It's being conceptualized into a new application. Civil have to be coming, mechatronics have to be in place, material have to be in place. You can never do without materials. However, material can also never do. Apply material differs. You want to apply your materials in aerospace. I'm not going to apply my material. You want to apply your materials in biomedical. No, I want to apply my materials in polymer applications. So, but everything still boils back to material. So it depends on what you feel. Are you developing material, or are you? Understand what I'm saying?
Thank you so much, Prof. And I think yes, thank you so much, Prof. And I think that once again, on behalf of the organizing committee, we want to thank you so much for coming and for such an explosive contribution to this field. I think one thing that we need to understand is that materials is a foundational field, and it's also an evolving field. And I love the fact that you're talking about the integrated approach to engineering, because we are in that state right now. If Corona is anything to go by, it's taught us that it is the confluence of all these fields of biotechnology, information technology, like machine learning and stuff like that, and then materials. What is the essence of designing a material by a chemist, which cannot be then used by a materials engineer to design a product? So it's an entire value chain. And Prof, thank you so much for such incisive discussion that we've just had. I wish we could continue this going forward, but I think that I'm looking at the time. And so, Prof, once again, thank you. Now, I quickly want to tell us the next phase of this particular, the next phase of program. We are going to be moving into